All right, so this is lesson 5.4, standard form of the equation of a line. And right now we are going to take a look at graphing in standard form. We've actually done this kind of graphing before. Again, if you remember when we were trying to solve those systems where you had dimes and nickels, and then you had two equations and you graphed both equations and you looked to see where they intersect. That's basically what we're doing, but just in generic format. There's no, the variables x and y don't mean anything here. This is, remember, this whole unit is on the theory, so we don't look at actual scenarios. Okay, so let's just do a little bit of a reminder. The x-intercept, sorry, an intercept is where the relation or the line crosses the x-axis. So on this graph, the x-intercept is right here. It crosses the axis, in this case, at -3, 0. The y-coordinate at that point is 0. So the x-intercept in this case would be -3, 0. But it's not always -3. I mean, it doesn't have to cross at -3. We actually just call that A. Whatever it is. So in this case, A equals -3, just for this particular graph here. That didn't come out very well. Let me just try that again. So A equals -3 in this case. And then the y-intercept is where the relation crosses the y-axis. So the x-intercept is where does it cross the x-axis. The y-intercept is where does it cross the y-axis. So in this case, this is crossing the y-axis at 4. The x-coordinate, so this is the point. Let me just go back here for the x-intercept. That's the point -3, 0 in this case, -3, 0. And then this is the point 0, 4. So the x-coordinate for the y-intercept is 0. And the y-intercept at that point, we always call the y-intercept b. So that would be the point 0, b. So in this case, b equals 4 because it's crossing the y-axis at 4. Remember, in y equals mx plus b, the y-intercept is called b, and it's always called b. And we just use the x-intercept, we call it a. It doesn't show up in any formulas anywhere. Now this is a small case a. That's not the same as the a in standard form, ax plus by plus c equals 0. I've said lots and lots and lots of times, a small case letter and a capital letter mean different things. They are not interchangeable, okay? We don't say y equals capital MX plus capital B. That's not right. We say that y equals small case MX plus small case B. All right, so if you're a person who doesn't like capital letters, well, that's too bad. Or if you're a person that doesn't like small case letters, that's too bad. You have to use them. Okay, now, we've done this next part before, except we did it with, we didn't do it generically. We did it with actual scenarios, but now we're just going to do it generically with x and y, because that's what this whole unit is about, is what happens with x and y. We looked at actual scenarios to help us better understand what's going on. So now we're just doing it in generic terms. So to find the x-intercept, you let y be 0. Why is that? Well, it makes sense because on the x-axis, any point on the x-axis has a y-coordinate of 0. If I take a look, let me see. Let me just pick a different color here. Let's suppose I was looking at this point right here. Whoops. This point right here. 1, 2, 3, 4. That's the point 5, 0. If I'm looking at this point right here, that's the point 1, 0. On the x-axis, the y-coordinate is always 0. So to find the x-intercept, we let y be 0 and then solve for x. So basically, if I want to find the x-intercept, I'm going to let y equal 0, and I'm going to write that down. So 4x minus 5 times 0 plus 20 equals 0. Well, that goes away because it equals 0. So then 4x plus 20 equals 0. Bring the 20 over to the other side. 4x equals negative 20. Divide by 4. And x equals negative 5. That corresponds to the point negative 5, 0. 1, 2, 3, 4. There's negative 5 right there on the x-axis. And then for the y-intercept, I'm going to do the same thing, except I'm going to let x equal 0. So we get 4 times 0 minus 5y plus 20 equals 0. That'll be gone. Minus 5y plus 20 equals 0. Bring the 20 over. Minus 5y equals minus 20. Divide by negative 5. Don't forget divide by the negative. Don't forget to keep taking this negative with you. That's a big mistake I see a lot. And negative 20 divided by negative 5 is positive 4. That corresponds to the point 0, 4. 1, 2, 3. There's 4 right there. And then you would draw a line through those points beyond. Remember, we always go beyond. Oh, whoops. I'm in a different software here, so it's not doing the same thing as I did before. Okay. Part B, same kind of thing. Let's try. You try part B on your own. Stop the video, try it, see how you do, and then come back and check your answer. So for the x-intercept, let y equal 0. Whoops, that's not a 3, that's a 2. Okay, so 2x. I'm not even going to write down that 3y there because it's gone anyway. So equals 9 divided by 2. So x equals 9 halves. And just for graphing purposes, that equals 4.5. So that's the point 4.5 and 0. 1, 2, 3. There's 4. There's 5. 4.5 is right there. And then for the y-intercept, let x equal 0. And so I'm not going to write that first term down because it equals 0 anyway. So I'm just going to write down 3y equals 9. So y equals 3, and that corresponds to the point 0, 3. So 1, 2, 3 is right there. And so we draw a straight line with a ruler. I don't have a ruler, so sorry about that. You should be using a ruler. Through those points, beyond those points, don't stop at those points, go through them, go beyond them, and then arrows on the end. All right, and that's it. The rest of this is a worksheet for you to practice all of this, okay? Question number 5 is a little bit trickier. You may notice some kind of patterns in question number 4. Otherwise, in question number 5, just take that equation and rearrange it to isolate y, and from there you may be able to figure out the answer to those blanks. I will post those answers like I always do though.